Hello friends, welcome to video series on geography. My name is Manjunath and this is my blog. In my previous video I've explained about Earth's interior and in this video I'll be explaining about Earth movements. And the text file for the following video can be found in my blog. So in today's video we'll be discussing various topics that come under Earth movements. Earth movements are mainly divided into endogenetic movements and exogenetic movements. That is, the movements that take place within the Earth's surface and movements that take place above the Earth's surface. Endogenetic are the ones that are happening within the Earth's surface, and forces for them are also available within the Earth's surface. And exogenetic movements are the ones which are observed on the surface. The forces may be existing on the surface or below the surface. And in endogenetic movements, we'll see what is diastrophic movements and then sudden movements. So sudden movements, as the name itself suggests, they are sudden in nature, like earthquakes and volcanoes. And diastrophic movements are slow movements, where they exist or happen for millions of years, and the changes they bring in are significant, but they take place very slowly. And the first important movement is called epeirogenic or continent forming movements. These movements mainly involved in shaping of the continents, and there are two kinds of movements involved. One is upward and the other one is downward movements. They are also called as radial movements because they take place along the Earth's radius, or the line or axis passing through the Earth's radius. And then orogenic or mountain building movements. There are two movements involved. One is tension, other one is compression. So tensile forces result in fracturing of Earth, whereas compressive forces result in folding of Earth. We'll see that in detail. So orogenic movements mainly occur along the plate margins, that is the boundaries of the plates, whereas the epeirogenic movements occur within the plate region, that is within the interiors of the plate region. Coming to exogenetic movements or forces which are emanating outside Earth's surface or sometimes even within the Earth's surface, the movements can be classified as weathering and erosion. Weathering is a movement where a particle just falls from a rock and settles just in the region neighborhood of the rock, whereas in erosion, the particles which are weathered are carried away for a longer distances by erosional agents such as ice, water, sea, wind, etc. So in this video we'll study mainly about weathering, but about erosion we'll study later. In erosion there are different processes called as fluvial erosion, which is erosion caused by running water, and then glacial erosion, erosion caused by ice, movement of ice, and then marine erosion, and then erosion due to wind. And even underground water movement also causes erosion, especially we'll see this under karst landforms. So we'll study these under erosional and depositional landforms, but for this video we'll not go in detail about erosion. In weathering we'll study about physical weathering, chemical weathering, and biological weathering. So what are the forces responsible for the movements happening both within the Earth's crust as well as above the Earth's crust? The most important force is radioactivity, which is happening at the core. We know that radioactive decay at the core generates intense amount of heat. I've explained this in my previous video called Earth's interior. So this heat is mainly responsible for the movement of lithospheric plates or crustal plates on the Earth's which are part of Earth's surface. We'll see how this happens. We know that Earth is made up of concentric layers, of which crust, mantle, outer core, and inner core are the important ones. And with these, there are few other layers like asthenosphere, etc., which are not. Asthenosphere is significant in tectonics, but in usual, the thickness and its physical and chemical properties are not so significant. So what happens is, in the outer core and inner core there is intense heat generated due to radioactive decay. Also there is primordial heat or residual heat, which is left after the formation of Earth from a nebula, where the whole solar system came into existence from a nebula. So during the formation there was intense heat that was trapped within the Earth's interior. It is called as residual or primordial heat. So this heat along with radioactive decay is important because it generates movements on the Earth's surface. Let's see how. We know that when there is temperature differential between two regions, and if there is a medium which is liquid or semi-solid in nature, it can simply create circular flow of this medium due to differential heating. So here the outer core is very hot, whereas the upper layers of mantle are comparatively cooler. As a result, there is a convection cycle that develops within this region, that is the semi-molten layer, that is the mantle, allows its constituent magma or molten rocks to move in a circular pattern, and these are called as convection currents. We have seen how convection currents occur in a pot of water. Likewise, here also there are convection currents, and when this convection current takes place, the friction caused by these currents, that is the movement of molten magma and the lithosphere, helps in movement of lithosphere. And there are various kind of landforms which are formed due to this convection currents. The first one is ridge, where the rising limbs of two convection currents meet, and where the falling limbs meet, they develop a trench. So here the movement is mainly initiated due to the differential heat between outer core and mantle. So here the energy needed is supplied by radioactivity at the core. So tectonics, the same explanation. Tectonics is nothing but the movement of lithospheric plates under the intense heat of radioactive decay in the core. And then climatic factors are the important ones, which creates movements mainly on the Earth's surface. The climatic factors like wind and then precipitation, etc., are mainly responsible for erosional activity, and erosional activity is mainly responsible for movements on the Earth's surface. And the major driving force behind all these movements is the sun, because sun is the ultimate source of energy for all these things on the Earth's surface. And we know that various latitudes receive different amount of heat due to their position. We'll see that in detail later in climatology, but for now we know that equator receives greater amount of heat and poles receives lesser amount of heat, and there is this energy differential which causes the movement of winds, as well as it also brings various weather phenomena like precipitation, cyclones, etc. So all these factors are responsible for movements on the Earth's surface. And then rotation of the Earth produces importantly two forces. One is centripetal force, which is maximum at the equator, and then there is one more force called as Coriolis force, which is an inertial force, which also acts on objects which are moving on the Earth's surface or even within the Earth's interior. So what is Coriolis force? We'll see that in detail while studying climatology, but for now I'll just tell 2 points. One is Coriolis force deflects an object towards its right in the northern hemisphere and towards its left in the southern hemisphere. So just remember this 1 point. So rotation of Earth creates a force called centripetal force at the Earth's equator. We know that when there is a circle and when there is rotation of this circle, the force acts tangentially on the on the edges of the circle. So this tangential force is called a centripetal force. So for a spherical object too, there is a centripetal force, and for Earth, this centripetal force is very significant, which arises mainly due to rotation of Earth along its axis. So what happens is, there is a force that is keeping Earth, giving the Earth its shape. For example, there is a force that is acting towards the center. This is called as gravitational force, and there is a force that is acting away from the center, and this is called as centripetal force. That is, centripetal force is acting outwards, whereas the gravitational force is acting inwards. But at the poles, there is only one force, that is gravitational force, but centripetal force here is zero, because this part of the Earth is not thrown towards the outer parts of the Earth, because to keep it simple, this part is not rotating. This part is stable, whereas this part or the equator, the regions along the equator are at greater speed compared to the ones at pole. So it's simply the velocity or angular velocity that plays a major role. At the equator, the Earth is spinning at a greater speed, or I can say the parts of the Earth are moving at greater speed, whereas at the poles, the region is completely static, that is, it is not moving. So the centripetal force is maximum at the equator and least or zero at the poles. So let us consider that there is a gravitational pull of about 10 Newton acting on a body at the equator, and let us say the centripetal force is acting outwards and it has a force of about 2 Newton. then this force will be the resultant force will be towards the equator by cancelling out the external additional force, and the resultant force would be about 8 Newton. That is, a body here would would be subjected to a resultant force of 8 Newton. So let us see exactly at the poles. At poles there is only one force, that is gravitational force. The force acting on the object would be about 10 Newton. As there is no centripetal force, there is no force acting outwards, so the total resultant force acting on an object which is at the pole would be 10 Newton. So we can see at the pole the force is greater, and at the equator the force is comparatively lower, that is it is 2 Newton less because of centripetal force. So what happens is, due to less force, the parts of the earth moves away from the center, that is they get extended from the center, giving rise to a shape called geoid, or a shape where the earth's equator is bulged whereas the poles are flattened. So you can see there is 10 Newton force which is keeping this region intact, whereas here it's only 8 Newton force. So due to less amount of force acting, the shape of the earth would simply move outwards, and there will be an equilibrium at a certain distance, and at this distance the shape of the earth would get fixed, and now it would lead to a geoid shape. So it is a slow movement which has taken for few billion years, and this is due to rotation of earth. So rotation of earth is the major reason for geoid shape of earth. So the other force, Coriolis force, is mainly results in the formation of cyclones, which are very significant, and these cyclones change the weather patterns on the earth's surface, which in turn results in differential erosional and depositional processes. So even Coriolis force is important in influencing earth's movements. And there is one more important concept called isostasy. For GS purpose, isostasy is not an important topic because it is only meant for optional students. So it is an important topic in optional geography optional, but for GS we need to know only basic nature of isostasy. So we need not go in depth. So what is isostasy? For this, let me explain with a simple example. Let us consider there is a tub of water. This is the tub of water, and we put a bowl in this water. Then usually the bowl would float depending on its weight. Now if we keep on adding some solid material to this bowl, then the bowl would start sinking slowly, and there would be a proportionate rise in water level around the bowl. So what is happening is, there is a balance or equilibrium which is being achieved by this process. So we keep on adding more and more solid material or something that's heavy, the bowl would keep sinking, and there would be a proportional rise in the level of water. So the same thing applies for even on the earth's surface. Earth has different landforms which are with varying densities, and also their weight would vary depending on densities. For example, rocks are denser whereas soil is less denser. So a rock would have greater weight for a certain volume, and the same volume of soil would have less weight. So what we see, a heavier material usually sinks, whereas the lighter ones usually rises upwards or floats. So this is the same happening in isostasy, where there is a balance achieved between denser landforms and less denser landforms. For example, mountains are the ones which are less denser, though they are rock, but the bottom layers of mountains are not so dense compared to other regions like plains or plateaus. Usually plateaus have much denser regions below their surface. As a result, plateaus usually are flat, or they exist, or they sink towards the center of the earth, whereas mountains being lighter they raise upwards. So this process attains an equilibrium of weight between various regions. So the mountains being lighter will float above the surface, whereas the plateau bottoms, which are thicker or denser, floats or sinks towards the earth's interior. Let us see what happens when a mountain has glaciers and there is accumulation of ice over the mountain top. So if you see, due to a very cold climate at the greater heights, there are glaciers which are formed. That is, glaciers are mass of ice. So the mountains gets heavy as and when there is ice that is accumulating at the top of the mountain. As a result, the mountain would get heavy, and as a result the mountain would sink, and there would be an equal amount of rise in the surrounding landforms. So there is a balance that is achieved by this process. And let us take, there is intense global warming, and this all the ice got completely melted, and in such a process the mountain would be much lighter, so it would rise upwards because it has lost some weight in the form of melting ice. And this, in this case, the earth would move, the surrounding regions would sink by a certain depth. So this is what isostasy is, the balance or equilibrium which is attained with respect to of weight on the earth's surface. So we need not study this in detail, just a basic understanding is enough. So let us look in detail about earth movements. We have seen what are these movements are. First we'll study about endogenetic movements. Under this we'll see what is diastrophism and sudden movements and all the related subtopics. So in endogenetic forces, the first one is diastrophism, which are slow movements. Diastrophism is nothing but slow bending, folding, wrapping and fracturing of the earth's surface. So these terms are the basic for our study of geomorphology. So what is folding? Folding is nothing but a bend in the surface of the earth or in the lithosphere, which is mainly due to forces of compression. For example, let us take, this is the landform, and when there is force acting in both directions, that is the force which is compressive, then this landform would change its shape, giving rise to a mountain-like structure, and this peculiar shape is called as fold. And in wrapping, consider this whole block of landform. So if this block is rotated anti-clockwise and if this block is rotated clockwise, then there will be a twisting or wrapping that occurs at the center, like we wrap a chocolate paper or something like that. So a twist would be seen at this in the center of the landform, and this is called as wrapping. So this is mainly due to rotational forces acting in two opposite directions at two opposite ends. So coming to fracturing, when there is compression in certain regions, there is also tension or movement away from the block. For example, if this block is subjected to movements in two directions which are in opposite directions, then there would be a break in this landform, and this block, one block would move to the right and the other block would move to the left, giving rise to a fracture in the center or a crack in the center, and this is called as fracturing. So these terms are important because they are the basic ones in geomorphology. And then diastrophism is all processes that move, elevate or build up portions of the earth's crust. So with folding also there are other processes like upliftment and subsidence. Usually upliftment leads to raising of a landform, whereas subsidence leads to fall in level of a landform. We'll see that in detail later. For now, in diastrophism there are two important subheadings. One is epeirogenic movements or continent forming movements, and the other one are orogenic movements or mountain building movements. Epeirogenic movements mainly occur within the earth's crustal interior of the tectonic plate, whereas the orogenic movements occur at the margins of the tectonic plate. Let us consider this to be a tectonic plate. Let us say this is Indo-Australian plate. Then all the plate, the part of the interior of the plate would undergo epeirogenic movements, whereas the margins would undergo orogenic movements. So what is the difference? Epeirogenic movements are the movements that occur over a very vast area where the changes, even though are very significant, but still we cannot perceive them from a smaller distance. This is because these movements take place over a distance of few thousand kilometers. So even this huge change would not be so imperceptible for human eye. That is, we don't usually find this peculiar, or it just simply looks like an ordinary landforms. Usually, if we say over 1,000 miles, the shape of the surface would look like this. That is, it has some wavy structure, then it might be elevated and then it might subside. But as we cannot see beyond few kilometers, for us, a person standing here, it would still look like a flat region. This is because of the greater distance of over which these movements take place. So epeirogenic movements are very large in scale, and there is also folding, wrapping, fracturing happening within these movements, but these movements being larger in scale are not clearly visible for human eye. But if we take the image of a satellite, then you would definitely get a clear picture about what an aperogenic movement is, how there is huge change in shape of landform over a greater distance. On the other hand, orogenic movements are very peculiar and they are very highly perceptible, because for example, let us take Himalayan mountains. From even few kilometers away from the mountains, we could easily identify the shape of the mountains. So they are very clear to the human eye. This is because they take place within a very small region. For example, Himalayas are only about 400 kilometers to about 100 to 400 kilometers in width. That is, they are so narrow in the region. Their length may be varying, but their width is so small, so it can be clearly visible for the human eye. So orogenic movements are the movements that take place within a small region, but they might be in very lengthy, that is, they might extend for thousands of kilometers. So orogenic movements also mainly form due to compressive forces, that is, where there is compression acting on this block of earth due to forces generating from within the interior. You know that how convection cycles within the earth's mantle influence the movement of the earth's lithospheric plate. Let us think of a movement which is happening this way. For example, a part of the cycle, that is convectional current, is moving into opposite directions, then there would be a force, compression force, on the two ends of the block of the earth, and in such a case there would be folding of the region in between them. We can see these are folds. So the folding can be towards the center or away from the earth's center. So usually the ones that are towards the center are called as synclines, and the ones that are standing away from the earth center are called as antisynclines. So this shape is antisyncline, whereas this shape is syncline. Even these two terms keep on appearing in books. So this is what antisyncline and syncline means. So the next important aperogenic or continent forming movements, these are nothing but broad undulations. As I've already told you, they occur over large distances, so they are not clearly visible. For this, a vast continental area could be visible like this from above the earth's surface. So this is what is aperogenic movement is. So aperogenic movements are continent forming movements. They usually shape the continents. And again, there are two important movements. One is uplift and subsidence. That is, depending on whether they move away from the center of the earth or towards the center of the earth, we take them as upliftment and subsidence. So upliftment is away from the center, whereas subsidence is towards the center. So these are also called as radial forces because they act along the radius of the earth. And the movement is caused by a set of forces acting along the earth's radius. For example, isostasy and faulting. We have seen that isostasy mainly occurs towards the earth center or away from the earth center. Faulting is a different concept. Faulting is usually a sudden movement, but it is an example for radial movement. And the central parts of the continents are also called as cratons because they are different from the margins or the edges of the plate, and the name given for interiors is cratons. So in the aperogenic movement, the first one is upliftment, and there are various examples for upliftment. These are called as raised beaches. Usually we see these near the coastal areas. And then we have got terraces, and there is something called as fossiliferous beds, and this is called as sea caves. So all these are example for uplifted landforms. We saw what are these upliftment is. So when you take, this is earth and this is the center of the earth, so the movement that is happening away from the center is called as upliftment. So this is the radial movement that is acting along the center or along the radius of the earth. And there is one more movement which is called as subsidence. Usually in subsidence the movement will be towards the center, that is, there is sinking towards the center of the earth, and this is subsidence. So in uplifted, for examples for this uplifted landforms are Koringa near the mouth of Godavari and Kavaripatnam in Kaveri Delta. Koringa is a very important place because it's a wildlife sanctuary. It is a marine forest or mangrove forest and is also a bird sanctuary. So it would be a good question under environmental section and an important one for prelims. And then Kavaripatnam is an historical place in the Kaveri Delta. These two are the examples for uplifted landforms. And then coming to subsidence, subsidence is the exact opposite of upliftment. So we have seen what is subsidence, that is acting towards the earth's center. The movement will be towards the earth's center. So usually subsidence creates depressions on the earth's surface. Depressions are the places which are filled with water and they are called lakes. So lakes are mainly formed due to subsidence. So there are examples like this region of the Andaman and Nicobar belt, which is submerged under the sea. This is the part of Arakan coast. Arakan coast is the coastline of Myanmar, and this is extension of this coastline, that is Andaman and Nicobar island chain is an extension of Arakan coast. This is a continuous land few millions of years ago, but now only certain parts of Andaman and Nicobar islands are visible, whereas other parts are got submerged below the sea waters. So this is an example for submergence. Other good example is Park Strait and Gulf of Mannar, that is the region existing between Sri Lanka and India is also a submerged landform. So these are two important examples for submerged landforms. Other important one is Gulf of Kutch. Even Gulf of Kutch has undergone subsidence over a period of time. For example, let us consider the city of Dwarka. Dwarka was a flourishing city few thousands of years ago, but now most part of the historical city is at the surface of ocean bottom. So this is mainly due to subsidence. And next, moving to orogenic or mountain forming movements.